Hi, in this example, we'll see how to use NLP preset to solve tasks with text fields. In this example, we will use toxicity dataset from Kaggle competition, where the task is to classify every comment if it's toxic or not. Here's how it looks like. Then we split our data in train and test and create NLP preset model. Here we specify roles for our features. We drop some of them just because we are not interested in them in this example. And we set toxicity as target. Yes, and also the important part is that we need to provide model with a text field, and we specify text as our text column. If we want to use tabular NLP AutoML, we need to specify the model that will be used to extract features from the text. These are the models that we were talking about in lecture. So if we want to use WAT model, then we need to specify its name here and also its parameters. For WAT, it is coefficients for summing up embeddings, and also whether to use SVD or not. For BRREP, there are a bit more. The main ones of them are projection size, sorry, and also what kind of pooling to use in the end. For random LSTM, there are a bit more also. As it is a LSTM, we need to specify the size of embeddings and also the hidden size. Then we specify the pooling and the number of layers in our bidirectional LSTM. But in our case, we have a lot of resources and we don't need to use these simple methods. We will fine-tune BERT model. Here we specify that it will be BERT tiny. We don't need more for our task. And we also specify the training parameters. Batch size, number of epochs, length of text, and learning rate. Then we train our model as usual. Here is the log of our training process. And in the end, we can see that this simple pipeline allows us to receive 97 or 98 almost percent of our croc, I guess. Yes, it is our croc or rock oak, which is quite a lot, because we didn't really do much. But also it takes us 1 hour with 10 minutes. And it's not really much for text models, to be sure. Now let's talk about how to interpret our models. And in lecture we talked about two methods, LIME and L2X. Let's start with LIME. To remind you, it works as follows. We take specific text, then copy it several times, remove some words in each copy. Then for each copy we make predictions using our model, which we want to interpret, and receive scores, which we will then predict with the first lasso model, which extracts some coefficients and zero out features will be removed. And then we train a final rich model that extracts importance of each word. Really simple pipeline. And to use it, we call Lime Text Explainer. We wrap AutoML model in it. And then we can start explaining. To do it, we call method explain instance and pass particular text into it. Also, we specify which column contains text. In our case, it's the only one column. Then LAMA returns us this visualization. Here, blue words means class number 1 with one ID, which is toxic in our case, and red words class 0. And opacity of this highlighting shows the importance for the model. And surely these are toxic words, so they are highlighted the most. Another example with toxic sentence, and here we have two really toxic words, so they're highlighted because only they are important. Okay, let's try to play with our model. What if we take this toxic sentence and replace all toxic words with good boy? We can see that prediction of our model dropped significantly from 92% to only 15%. And good positive words were highlighted as 0 class. Also, we can take non-toxic text or neutral with small percentage of its being toxic and try to do it more toxic. Okay, we will add some bad words and try to interpret the prediction of the model. We can see that the prediction turns to be big, and the model thinks now that this text is toxic, and surely it has a bad word. What if now we add some happy words? For example, just happy something. The prediction now is only 51%, and the model highlighted happy as non-toxic word. Now we can add more happy words, and we received that sentence with all happy words highlighted as non-toxic, and the model prediction also drops. So, as we can see, Lime interprets the words quite well. And what about L2X? Here we will retrain our model on another dataset with some larger sentences. We will use Beer Advocate dataset. It contains description of alcoholic beverages and some characteristics of each beverage. Here there are 5 of them, and we will use overall appearance as our target. So we train our NLP preset in the same manner, but now we use Baird Bayes Encased, which is a bit larger. And let's see what we have. So we have some score, doesn't really matter what it is exactly. Let's move on to L2X. Here is the schematic pipeline of its implementation. I remind you it trained 2 models. The first one assigns probability of, you can think about it as an importance of each word in the text. And then sample K most important words and give them to another model. So here's the sampling. It's using Google Softmax, but it doesn't really matter. So here is the most important words, which then are passed to the second model, which tries to predict the target, which is our original model predictions in this case. So here's the pipeline. We can call it using L2X text explainer, pass some training parameters to it, and feed on the whole dataset. We can also pass validation data here, but it is not necessary. Okay, now we have a model that can show us most important words for any sentence in our dataset. In order to do it, we we take a review column, which contains text from this L2X model, and ask it to explain instance. Here we can pass arbitrary number of instances, and it will explain it all. Here we have a list of explained text instances. And we can call visualize in notebook method to have these beautiful visualizations. I remind you, in our task, the target was appearance of the beverage. So we want to see that model focuses more about how the beverage looks like for a drinker. So let's look what it extracts. And yes, the words are brown color, some aroma for some reason, and yes, light copper. So here are some words that describes appearance really. Okay, yes, here is also dark yellow color, no much head, and etc. Okay. So here is the simple example of how we can build an NLP preset, train a model that achieves high quality, and also how to interpret its outputs. Thank you.